Hello everyone, my name is Anil and in this video I'm going to give you a demo of my recent project called Deep Face Authenticator. From the name itself we can say it's a face recognition system. So coming to the problem statement, the requirement received was to build a face recognition system containing of two stages, where the first stage will be the manual authentication and the second stage will be the face authentication. So in this project the solution we proposed was even though there are many face recognition systems available already, the approach we are followed in this project was face embeddings approach. It is like the user's image will be captured and from that image the face will be detected and it will be given as input to the um, FaceNet model. Using this FaceNet model, the face embeddings will get extracted and will be stored in the database. So we can use these face embeddings further, for face verification process. Let me give the demo of this project first, and later I will explain the architecture. See, this is the index page of our project. The new user has to be registered in the uh, database first. For that, he has to click the sign up here, and he need to provide some basic details like name, email ID, phone number, and password. Let me give here. See here, the user details will get stored in the database first. This user details collection. See here, the size, username, password, email, phone number, and UUID. See here, the password will get stored in the hash format, not in the password he provided directly. And UUID will be generated uniquely for each user and will be stored along with his details. So upon um, registering his details, he has to register his face embeddings as well. For that, he need to capture his face images and input to the models. So let me capture. This system is accepting eight images as input. We can modify this in the backend as well. And after clicking the images, he has to click generate embedding here. So the model will, will detect the faces from the image and later the embeddings get generated. You can see that here. The pre-trained model for FaceNet and MTCN is being loaded. Here the embeddings has been generated for each image, and the average of all those embeddings will be calculated, and that average embeddings will be stored in the database. This embeddings details collection and the embeddings will be stored. The UUID generated for the user we registered will be used for the embeddings as well. See here for the Sai user, the UUID generated is the last four digits for FF 334. Let me check with the embeddings as well. See here, the embeddings will be stored with the same uh, UUID. So these embeddings will be can be used for further verification as well. Now let me log in into the system and check. See, the user has been logged in successfully. Now he has to give the image to the system so that it can verify if he is um, authenticated person or not. It is taking one image as input. This also can be modified. See here, the user is authenticated. We can check the what has happened on this login. See, the cosine similarity has been calculated for the embeddings of the logged in user, and it is 91, and the threshold we set was 0.75. Since it is greater than the threshold, it is accepting, and uh, user is authenticated successfully. The whole process is taking time of 2 seconds for logging in, which is nearly real time here. So this is the demo of the project. Let me show the architecture of the project we followed here. Let me close this as well. This is the architecture followed in this project. See here, the user is the whole flow of the project is shown in this architecture diagram. There are four routes um, created for this project. The first route was the register route, and the second route was the login route. Then, if the user is new to the system, he has to register first by giving these details, and these details will be stored in the database. Then the third route was register embeddings, and after registering the user, he has to register the embeddings as well. We have given the input image to the system, right? The face detection system we have used is MTCNN here for detecting the face of the user, and later that detected face will be given as input to the uh, FaceNet model. This FaceNet model is responsible for extracting the embeddings of the user, and those embeddings will be stored in the database. Later, the user can be log in and give his image to the verification process. The same algorithm will be used for face detection and the embeddings extraction process. And after extracting the logged in user face embeddings, it will calculate the similarity check. Here we are using cosine similarity for the comparison, and uh, if the result is greater than the threshold, he will be authenticated. Otherwise, he will be uh, not authenticated. Redirected to the login page again. This is the demo of the project. Thank you for watching.